Good morning, my YouTube viewers. Crystal here. It's early in the morning and I decided to go ahead and make another video for you. This video that I'm making for you today is going to allow you to compare the UK and the US COVID new cases and COVID new deaths per million, because I just felt that it would be a good idea to compare their cases per million. And the reason why is because you have less people in the UK than you do the US. So you're probably going to have less cases in the UK than you do in the US. So it's not going to be a very accurate statistic to say, well, you have less cases in the UK than the US because you've got less people in the UK and the US than the US. So it's better to carry out an analysis of cases per million. So I think you've got 68 million people in the UK, and I'm not sure how many million people you have in the US, but if you carry out new cases and new deaths per million, that's going to be a more accurate indicator than just carrying out new deaths and new cases and new deaths. So I've been working on this program this morning because I had some bad news. So I found out that my brother was in a head-on collision, and so I didn't want to go back to sleep. I was wide awake after that. I found out quite by accident. I found out on a YouTube video because I'm not communicating with my sister or my brother because of things that I can't go into here because this is a technical video. It's not a personal video. But anyway, I just wanted to explain to you that I didn't want to go back to sleep and the reason why. So that's why I'm up so early in the morning. And so now that you know why, without me going into too much detail, what we'll do is we'll carry on with the code review. So the first thing that we'll talk about is what we did was we used the data set from ourworldindata.org, and this CSV file is updated every single day. So every single day that you work on this CSV file, you have to upload the most current version of the file. Now, I checked it twice this morning, and twice this morning when I checked it, it hadn't been updated yet. So I'm using yesterday's version of the file since I can't get an updated version of the file. But that's what you have to do, because this CSV file is updated every day. Every time you use it, you have to use the most current update. And I am using the most current update because it hasn't been updated yet. I also found out that there is actually a file on GitHub that you can use that's updated every day, and I suppose it's updated automatically, but I just decided that I would rather than use this file on GitHub, because I don't know the GitHub account, I'll just save it to my Google Drive and use that one and re-upload it every day that I'm using. So what we're doing now is we're going to compare the US and the UK new cases per million and new deaths per million. And what I'm going to do is I'm going to show you the technique that I use to come to the point where I could make this comparison. And although I'm comparing the US to the UK, if you are living in another country and you want to compare it to another country, it's a very easy matter to just swap out the US and the UK for other countries, because I showed you the basic technique with the US and the UK, and it's not going to be that difficult to do it with your country, the country that you want to do it on. So I wrote this program on Google Colab because Google Colab is a free online Jupyter notebook, and I can work on it any place where I've got a computer, because I go someplace 14 hours a week, and I use the computer 14 hours a week, and because it's online, I can work on my Google Colab when I'm using that computer as well if I want to. If I've got the time and if I want to, I can do it. So that's the good thing about Google Colab. Any place you've got a computer and internet access and have access to Google, you can use that online Jupyter notebook, which is what I use. So we used Google Colab. Google Colab has many of the libraries already installed on it. So all you have to do is import it. So we imported Pandas and NumPy. And NumPy is a numerical library, and Pandas is more like a string library, and it does all kinds of neat stuff. So what we did is we loaded our data set, and I've already told you about the data set. I'm using the most current version because it was early in the morning when I started working on this, and they hadn't updated it yet. And I looked for updates around 6 o'clock when I completed the program, and that hasn't been updated either. So I am using the most current version. So what we do is we want to do an info. So we want to find out as much about this file as we can. It's got a total of 52 columns, and most of the columns are floats, but a few of them are objects. So now what we do is we want to do something with the date. So we import date time. Date equals train date. Train date equals PD to date time. Train date errors equals converse. So what we're doing is we're converting the date in the column to a date time. And then train date num equals train date DT STRF time, and then train. So now what we do is we created another column. We created another column, and we called it date num, and we converted the date to a numerical number. And the reason why is because when we start carrying out our predictions, most models are going to want to see a number. The only model that I know of that will accept floats is CatBoost, and then you still have to do something to the CatBoost to get it to actually accept a float. Okay, and then what we want to do is we just want to find out what country we're on, how many countries we have. So what we do is we say country equals train location to list. And what we've done is we've created a list that has all the countries in it. And then we put another line of code in there. So if the list country is, what we're doing is we're taking out duplicates is what we're doing. So list country equals empty bracket for I in country. If I not in list country append list country. So now you're seeing a list of the countries that are in there, and it's 192 countries. But one thing that whenever we go through and start doing our work, it's only 191 columns. So somehow or other, one of the countries slipped off, and I'm not sure exactly how that happened, but that's just something that happened, and it wasn't anything to do with me. So you can see a length of this file is 192. That means that there are 192 countries in the list. But as I said, when we start doing our work, it's only going to have 191 rows. So that means one of the countries is going to be slipped off. And I don't know which country is going to be slipped off, because what I would have to do is I would have to perform a comparison. And I could do it if I wanted to do it, but I would have to perform a comparison of like the last days and see how many countries were in the last day, which is 191. And there's going to be one country missing, so we'd have to find out which country was missing. So we want to get the latest date. So last date equals date max last date. So the last date is 2020-12-26 because that's the most current CSV file that I'm working with. And then what we want to do is we want to convert that date to a date time. So from date time, import date time, we format it. DT equals date time, strip time, last date format. So now we're formatting the last date into an actual date. And now what we want to do is we want to add one day to that date. So next day equals DT plus time delta, days equals 1, print next day. So 2020-12-27 is the next day, and that was yesterday. So now what we want to do is we want to create a code for the last date. So last date equals train.date equals train.date max last date. So the max is telling you that that's the very last date because they're using max. And so let's see what happens here. But the date num is still on the 26th. The date num still says the 26th because we're on the 26th. That's why the date num says the 26th. But yeah, last date equals train.date equals train.date max, and that's your last date. So that's the 26th. So now they have a graphical representation. We have a graphical representation of the new cases. We have another graphical representation of train, new deaths. We have a graphical representation of the new cases across the location, and there's 191, 192 locations, so it's really difficult to get all of them in there. And then the same thing with deaths across the location, but because you've got 191, 192 locations, it's hard to get all of them in there. So what we've done is we've done a box plot of the continent, and we wanted to find out how many new cases we have in the continent. And we have the most new cases in North America, but I think that is because that is because more people in North America are getting tested. It doesn't necessarily mean that there's more cases. It just means more people are getting tested. Because a few months ago I was sick. I think I had the shingles, but I'm not sure. But, I didn't want to get tested. I rang up the 111 people, and they said, well, we don't think you have it, so don't worry about it. But I wouldn't want to be tested anyway because I don't want to be part of their statistics. But I think that's why they have a very high percentage of people in North America as having this COVID, because more people are being tested for COVID, and I don't want to get tested for it. I had to get tested for antibodies once because of where I work, and they said that I didn't have the antibodies, so that means that I didn't get it. So now what we want to do is we want to do the new deaths. So this is the new deaths, and again, it's like you've got North America, you've got quite a few, and then South America has some outliers. So North America has more deaths than any other continent, but that's because they have more people being tested for it. And because they have more people being tested, that if the people will die, then they can record it on their death certificate that they died from COVID. So now what we've done is we've done a heat map. So if you like heat maps and you want to see how all of the different variables relate to each other, well, here you go. Here's your heat map. So now what we're doing is we're going to be getting into the actual analysis, which is the purpose of this video. So we've got the UK. So country equals UK, and we use some code to actually just filter out the UK COVID-19. So we have a graph of the new cases. And again, I've discussed this in my previous videos. We had, you can see right here under 53150, that's probably like when we had around the first lockdown. So we had the first lockdown and then the cases went down, and now we've got a lot of cases again. And the reason why is because this COVID-19 has mutated, and because it's mutated, it's much more infectious than previous COVID-19s, which is why we have to wear masks everywhere we go. And it's probably fortunate that I'm not that sociable a person. Well, I am sociable, don't get me wrong. I am sociable, but people don't want to socialize with me. So it's fortunate that people don't want to socialize with me, so I don't get close to too many people, and so I haven't been exposed to this virus. But as you can see, that because this virus has mutated and it's much more infectious than the previous virus, we're having a lot more cases now than we had in the first lockdown. And as the time of this video, we've got 3 mutations. We've got one mutation coming out of London, one mutation coming out of South Africa, and another mutation coming out of a North African country. I don't remember exactly which country it is, so I won't name it. And now what we're doing is we're graphing the new deaths. And as you can see, in the very beginning of the lockdown, we had lots of deaths. And then the deaths started increasing, so they got a handle of the deaths. But now the deaths are creeping up again because of this mutation, because this virus has mutated and it has become much more infectious than it previously had become. So now we've got new deaths per million. So you can see this is new deaths per million. And now we're going to look at the United States. And basically what we did was we filtered out the United States. So now we've got a data frame with just the United States. So we're going to check the new cases in the U.S. And you can see that the cases in the U.S. are steadily creeping up. And the reason why it's steadily creeping up is because more people are being tested. We have the number of deaths in the U.S. So you can see that at the beginning you had a lot of deaths, and then the deaths reduced, and then the deaths were reduced, and now it's creeping up, and that's because the virus has mutated, and the mutated virus that's coming out of the UK has actually made it to other countries, and I'm sure it's made it to the US because the US is English-speaking country. So the UK and the US have very close ties because they both speak English. So now we're going to check new deaths per million, and you can see that they've got quite a lot of new deaths per million. So now what we want to do is we want to do a comparison. We're going to compare the new cases per million to the new deaths per million. So you've got a lot more cases than you have deaths worldwide. And here, again, we're going to compare this is in the U.S. You've got a lot more cases than you have more deaths worldwide. So we've got another chart. So let me go back and see what these charts say. So one is new cases per million, new deaths per million. That was overall for the whole chart. And then the one down here is the US. And the one down here is the UK. So we have a lot more cases than we do deaths. So that means a lot of people are recovering from this virus. But not everybody's recovering. That's the problem. Now what we're going to do is we're going to compare the US to the UK. And whenever I was doing my comparisons, I found out that the US started making statistics about 9 days before the UK started making statistics. And as a result of that, and you can see it, I'll show you up here. As a result of that, when I tried to combine the two files, they would not combine because you did not have the same number of rows. And if you don't have the same number of rows, that's going to be problematic. So what I did was I found out that I had to do this through trial and error, but I found out that they have 9 more rows than the UK's. So what I did was I chopped off the first 9 rows of the US one. So the date starts at January 31st, 2020 to be in line with the UK one. And then what I did was I checked the shapes of all of these columns that I wanted to test, and the shapes were all 331, which I wanted to see. And then what I did was I wanted to create a new data frame called UK versus US, and you can see that this UK versus US, they had 662 rows instead of 331. So half of the rows were for the UK and half of the rows were for the US, and that's not what I wanted. So what we've done is we had to create another one. It says UK US 1 equals UKV US 0 to Lynn UK COV19. And then we dropped US date, US cases per million, US deaths per million. And then so now on this UK US 1, it's just UK date, UK new cases per million, UK new deaths per million. And let's see what we've got here. So we changed on the UK US 1, we changed the date, the column from UK date to day, changed that name. And then UK US 2, and what that starts out, it starts out for the length of UK COV19 all the way to the end. So it's 331661. And then we delete the UK date, UK new case per million, UK new death per million, axis 1. So we just have US date, US new case per million, and US new deaths per million. And then we change the name of the column US date, we change that to date. And then what we do now is we merge these two newly created data sets. We merge them. So UK US equals PD merge, UK US 1, UK US 2 on date. So now we've got our new data frame, which has date, and it's only 331 rows, which is what we wanted. And so it has date, UK new cases per million, UK new deaths per million, US new cases per million, US new deaths per million. So now what we want to do is we want to check to see if we have any null characters. And yes, we do have some null characters, but since these null characters are in numeric columns, what I just did was I did a blanket UK US dot fill in a 0 in place equals true. So that just replaced all the null characters with 0. So now we get to our charts. We had to do all that work just to get to a chart so we can do comparison. And that should give you an idea of how much work is actually involved just comparing the US to the UK. And as I said, you can do that with any country. You can swap out UK for another country, or you can swap out US for another country if you're in another country. So now what we're doing is we wanted to compare UK new cases per million with US new cases per million. So you can see that the UK has less new cases per million than the US, but I think that's because more people in the US are being tested. And now what we're going to do is we're going to compare the UK new deaths per million with the US new deaths per million. And so it started out with the UK had more deaths per million, and then it tapered off. And now again, we're getting to the point where the UK has more deaths per million. So the UK has pretty much the same UK deaths per million as the US. So that's a good comparison. It's a good way to actually compare these two countries. So what I've done is I'm taking you through the process on how to actually, what you have to do to actually compare two countries. And I compared the UK to the US. And as I said twice before, if you're not living in the UK or the US and you're living in another country and you want to compare the country you're living in within another country, then you can just swap out the UK for the US and use the same procedure. You might have to do a little bit of work with the columns, but if you're having problems with that and you need my help, then certainly message me and I will try to help you. But that's the only thing that I see you're going to have difficulties with. So now what we're going to do is we'll go ahead and finish the program since we've got this far already. And we're about 2/3 of the way finished anyway. So now we're going to check for the null values in the train file. So we're going back to the train file now, back to the original file. And you see that we've got loads of null values. And so what we wanted to do is we wanted to drop the date. We're imputing the missing values now, and we wanted to drop the date. And so what we had to do was we had to find out which columns were objects. So we used some code to find out which columns were objects. And then we decided that we were going to impute the categorical columns. So all the categorical columns that had missing values, you're going to say not listed. And now, since all of the categorical columns have been imputed, now what we can do is we can just impute all of the numeric columns. And I decided to just put 0 in all of the numeric columns. Now what we're doing is we're putting the data frame through an ordinal encoder, because all of these categorical columns, they're not going to get through the model, so we have to convert them to a numeric format, and that's what the ordinal encoder does. And now what we do is we define our X and Y. So your ISO code equals train.iso code, and we define our Y, which is new cases and new deaths, because our Y is going to be a multi-label output. So instead of one label, we're going to have two. And your train is going to be, your X is going to be your train drop. All of these columns that deal with the new cases and the new deaths. We don't want to have any of that information in the data frame, because that's going to affect the reading. So we have to get rid of all of that. And now what we do is we put X on a standard scalar. So you can see Y here, and you can see X after it's been scaled. Now what we do is we split our training set up for training and validation. So X train X val, Y train Y val equals train test split XY, test size equals 10%, random state equals 1, shuffle equals true. And then we get the shapes of those as well. So we select our model, and so we're going to have a model equals multi-output regressor. We're going to use the history gradient boosting regressor because it's designed for large data sets, and we're going to fit it. And when we've trained the model and fitted it, we've got a 99.24% accuracy, which is pretty good. And now what we're going to do is we're going to predict on the validation set. When we predicted on the validation set, we had an 86.38% accuracy. And so now we check our Y-val to see what's in Y-val, and we check Y-pred to see what's in Y-pred. And so since our y-val is 2 columns of data, we check the first column of data, which is the new cases, and then the second column of data, which is the new deaths. And so we plotted that on a chart, and it doesn't look very good. So now what we're going to do is we're going to put the predictions in a data frame so you can see compare the actual cases against the predicted cases and the actual deaths against the predicted deaths. So now what we're going to do is, because it's not enough to predict on existing data, we need to be able to predict on new data. So we're going to create a test data set from the existing data. So test equals last date, test day equals next day, and then test. So you can see we've got our test file here. And so it's got the last date on it, which is 27 December 2020. And the date num is 26 December 2020 because that hasn't been changed yet. So what did we do? Yeah, because test date equals next day. So now what we want to do is we're going to take the test date num equals test date dt strf time and then test. So now you can come over here and we can see that our date has been changed to 27/12/20, which is what you want to see. So now we check for null values. We see we've got quite a few null values. And we had to do the same thing to the test file that we did to the train file. We imputed any missing values. So predict date equals test date. Test equals test drop date. Axis equals 1. We wanted to do a check to find out which columns were categorical columns, and we did that. So we've taken all of the categorical columns and any missing values we just filled in saying not listed. Now, since all of the categorical columns have been filled up, now what we can do is we can just do a blanket test.fill in A0. So we filled out all the numeric values with 0 now. So now you can see the test file. Test file's fully made up. And then what we've done is, because the categorical files will not go through the model, so we have to take the categorical files, we have to convert them to numeric files or numeric columns, and so we put it through an ordinal encoder. But before we put it in through the ordinal encoder, we create a variable called test country equals test.location. So we're going to keep this variable called test country. And you see it says 191 on it. So somewhere along the line, one of the countries has dropped off, and I don't know why that is. So now what we're going to do is we're going to define our X test. So we're going to keep our ISO code equals test.iso code. And then the test X test is we're going to drop all of the same columns that we had initially dropped with the train. So we're going to put X test on a standard scalar and scale it. So now you can see X test. So now what we're doing is we are predicting on the test set, and we have 191 rows with 2 columns. And the thing is so the first column is going to be the predicted cases, and the second column is going to be the predicted deaths. And what we've done is we've made a data frame with the country, the date, predicted cases, and the predicted death. And so when the CSV file is updated, then you can compare the predictions with the CSV file and find out how accurate it is. So that concludes this code review. So what we've done is we've covered how to compare the US to the UK with total cases per million and total deaths per million, and we just decided to go ahead and finish the code review on the program because we've already got the program here. So that concludes this video. If you like my video, please like, subscribe, and share. If you like the work I do and want to make a donation, then I've got my email address to my PayPal account in the description box down below. I don't have enough subscribers, so I have to ask for donations. And thank you so much for watching this video, and I look forward to making more videos for you in the future.